Okay, well, I hope everybody's having a good day. Hello. All right. So today I want to talk about any questions you might have on the assignment. We just turned in standard deviation. Then we'll wrap up our discussion about normal distribution. I'm hoping to give you a little time in class because for a lot of the normal distribution homework, which you picked up today, you will need a calculator. If you're not able to finish, you can definitely come in, during tutorials or just, come talk to me and we'll figure out a time for you to use a calculator if you don't have one. But this new assignment's going to be due on Friday. Okay, so I'll give you a couple days for that. Let's see, tomorrow we do have a quiz over what? Over standard deviation. Okay, so I don't think it's going to be too bad. Everybody seems to be doing pretty well. I have already completed the not grade book, the website for next week, and I've started uploading some materials. But while we have the quiz on standard deviation tomorrow, we are also going to have a normal distribution quiz this coming Tuesday the 10th. All right, so we'll turn in the homework on Friday. Hopefully we'll be able to finish up linear regression, and then all of next week, we're going to be talking about chi-squared test for independence. And it's probably going to take us at least a good 4 or 5 days to get through, simply because the amount of material that's associated with it. But it's very, very useful, especially for a lot of people when it comes to your IA. But let's go ahead and see where we have. First off, are there any questions on standard deviation? No? Oh. Do the first one? Okay. So the table below shows the weekly turnover of a small shop over a period during spring and summer. Okay, so it looks like we have our cells grouped into class intervals here. All right, and then we have the number of weeks. 2 fell between 0 and $99. Then we have 9, 15, 7. So find the mean weekly sales and find the population standard deviation. Now remember, when we do this using technology, we're looking for the sigma x. IB treats everything as a population, but we're going to go ahead and look for that particular standard deviation. Now, if I were to go ahead and do this by hand, which I'm not going to do, what do I have to use from those classes? I got to use the midpoint, okay? So what's halfway between 0 and 99? Okay, so we'll go ahead and say 49.5. And then you'll notice there's always going to be a pattern if the intervals are the same width. So we have 100 to 199, so that should be 149.5. And then, we'll go from there. Okay, so I don't have a copy of this in front of me, so I'm going to have to ask some folks to help me out when it comes to the frequencies, because I don't remember those. So let's say I want to put this in my calculator. All right. I know that I'm going to choose one, okay, a new document. Okay, list and spreadsheets. Okay, so X. Okay. I'm just going to go ahead and put in Y, but you can put in the frequency if you like. Remember to avoid the equals row. We're never going to put anything in there. The first value is 49.5. Then we have 149.5, 249.5, because all the classes are of equal width. How far does this go? To 349. Okay, so one more. 349.5. Okay. And then I remember the first one was 2, then it was 9, 15, and 7. Okay. So I've got all the data in. Now, where do I go? Okay, menu. Statistics. Okay, stat calculations. 1 or 2 variable? I got 2 columns. Remember, that's the frequency table, so there's still just one set, even though I've got 2 columns, 2 sets of data here, what appears to be. So 1 variable, I just go ahead and click OK past this. So the X1 list, we want to go ahead and make sure to choose the first one that we got there. Frequency list, we want to make sure to choose that column heading that I put in. And it looks like everything will show up in column D. Okay. So it looks like the mean, okay, using the midpoint, 231.32, depends on how many significant figures you want. Okay, 231 if you're going to say 3 sig figs. Let's see here. Standard deviation, so about 83.3. Okay. Remember, the standard deviation is a measure of spread. It's a numerical value that's going to indicate how close or far apart the elements in your data will be from each other. Okay, so
The quiz tomorrow, are we going to need to work it out by hand?
actually, I'm just going to let you, I'm all on the calculator. My original idea was I put a table on the quiz, and I was going to go ahead and have you fill it in, do one by hand. And I thought, we've done that. You're not going to be expected to do that on a paper exam, so I just altered the questions. Calculator's fine. That's really what we should focus on. Okay. All right, so that's a good question. Anything else? Okay, well, good, good, good. If you do end up having any more questions, let me know. Control W, there we go. Do you want to save those? No. Sure, I'll spend it. Okay. So let's see, I don't need that anymore. That's not what I needed. Okay. So what did we start talking about yesterday? Okay, normal distribution. Okay. So this is a way of looking at data where it's going to be symmetrical. So we have this bell curve right here. So this is the one instance where the mean, the median, and the mode are all what? They're all the same. Okay, so we got through several examples yesterday. Now, if you're being asked questions about specific standard deviations above and below a particular mean, well, then it's really easy to figure out. You just have to remember what the percentages of your data below the curve are going to be. It's if it's not at those specific standard deviations, well, then the technology is going to have to come in. So I thought we'll start today with a problem to kind of help everybody remember. It says, suppose the scores on a chemistry test were normally distributed, so we're going to have a graph like this, with a mean of 78, and we always use this symbol here, mu. Okay, so that's my mean. Okay, 78, and a standard deviation of 10. So a lot of times we like to look at the mean within 3 standard deviations. That means 3 above and 3 below. So I'm going to say here's 1, 2, 3 standard deviations above, 1, 2, 3 below. Okay. So how do I figure out what these values are going to be? Like, what would this first one above 78 be? There you go. What you would do is take the mean and you add that standard deviation over and over again. So plus 10 is 88, plus 10, 98, plus 10, 108. So if you add to go above, what do you do to go below? Subtract. So this would be 68, 58, 48. Okay. Now let's kind of talk about the area, the percentages we have below the curve. Okay. Now remember, this is symmetrical. So the 2 innermost areas are going to be congruent. Okay. The 2 outermost areas, and then as we go through. So can anybody help me remember, within 1 standard deviation, that should represent how much of the data? That is 68%. Okay, that's going to be 68%. Now, if these are symmetrical, that means this becomes 34%, and that becomes 34% as well. So whatever the data looks like, if I were to go ahead and start it from the smallest elements all the way to the largest, okay, for whatever these scores in this particular case are, that means between 68 and 88, that should represent 68% of the data. Okay. Well, can anybody help me out? Within 2 standard deviations, what's that? Now this one's in the 90s. 95%. Okay. So one of the first things we talked about yesterday was how to figure out those additional areas. Can anybody remember what did we find these two to be? 13.5. That's exactly right. 13.5, 13.5. Because if I add all 4 of those, I get my 95%. Okay. And let's go one more here. Give myself a little more room. What about within 3 standard deviations? Laura, can you help me out with that one? That's the only one that's going to have a decimal value. Within 3 standard deviations, you should have virtually all of your data, 99.7% of it. Okay. So what are these 2 little areas right here? And of course, they look bigger here than they really should be. 2 point. 35, there we go. So 2.35%. Okay. Now, some of these questions are going to be, very specific about the exact standard deviations, but then the last one is not. So I'm going to ask you what we do there. The first one says, find the probability that a student earned between 58 and 68 points. Okay, so let me use a different color here. Let's say green. So I want between 58 and 68. Well, this doesn't go through multiple levels, so what percentage of the scores should fall in that category? Should be 13.5%. Okay. See, just by knowing those percents, I was able to get that answer right off. It's really easy if they're using the exact values of the standard deviation. Okay, well, what about earn between 58 and 98? That's exactly right. Okay, I'm going to use another color here. Here's blue. All right. 13.5 plus 34 plus 34 plus 13.5 we talked about, that's 95%. Perfect. Now, look at this last one here. Earned 82 points or higher. Now, why are we not able to do this one by hand? There you go. Look at your standard deviations. Where's 82? It's going to be halfway between 78 and 88, right? So let me choose another, color here. Let's say purple this time. So if I were to say 82 is maybe right about here, I want to know what percentage of the data is 82 or above. I mean, so we're already going to have an idea. I could take 13.5 plus the 2.35, but how much of the area is going to be taken of that 34? That's the question. So how do I do this one? How did we do it yesterday? Now we go to the calculator. Okay. So let me come on over here. Let's see here. I keep choosing the wrong die. There we go. All right. So let's see here. Control W. Let's get out of here. Do you want to save that? No. Okay. So let's go to my calculate screen. How do I put this in the calculator? Okay. So I'm on my scratch pad. Menu. Statistics. Okay. Distributions. This is a normal distribution. We want normal CDF. Always, always CDF. Okay. So we want everything 82 or higher. So that means 82, you're what? Is that an upper or a lower? It's a lower. Okay, so I'm going to come on over here. I'm going to go ahead and type in 82, but I need both an upper and a lower bound. What do I do if there's no upper? Remember, just fill it up with nines. I know it sounds ridiculous. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Okay, there we go. That's okay. That's okay. That's okay. Well, I mean, a lot of things I say are funny, so I can't blame you. Okay. It's funny. Not a lot of people laugh when I make a joke. Right? Just an observation. Okay. All right. So what was my mean? Was it 78? Okay. And then the standard deviation was 10. Okay. So there we go. Now, before I go ahead and click OK, what if I had an upper but no lower? Then I would leave that scientific notation, the 9E, 9999999. Oh, not this time. Okay. 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 So I'm getting about 34.46. Okay. So it actually wasn't a whole lot of that sliver. Okay. Is that making sense? Go through the steps. Absolutely. So how do I get here? We went to menu, statistics, distributions, normal CDF. Okay. And now this is where I plug in my information. Mu is my mean. This is my standard deviation. And then we just need an upper and a lower bound. Okay. All right. That's what we've been working on since yesterday. Okay, cool. Cool. All right. So let's look at some notation. Okay. In general, to designate that a set of data is normally distributed, we use this notation. So a lot of times they may not verbalize it, especially on the paper exam, but if you see this right here, Okay, it'll say X, and this little symbol, you might recognize it first off as similarity in geometry. Okay, that little tilde symbol. Well, in here, that's talking about it's normally distributed. That means you're going to have the bell curve exactly like we were just talking about. Okay, and it's going to give you an ordered pair. The first value is your mean. The second value, well, it says sigma squared. What is that? There you go. That's the variance. Now, they won't actually have the value squared. What they're going to do is have the base with the power of 2. Okay, so if you realize if you square that value, you're going to have the variance. All you're going to be looking at is the base. So I know here that sigma, my standard deviation in the example, is just 2.3. Okay, what's the mean? 10. So this is telling me that the data is normally distributed, and here's my information. So given that, find the following probabilities. Okay. Now, we're going to go ahead and do the plug it in the calculator. Does anybody want me to go ahead and draw the normally distributed graph just for practice, or you feel okay with that? Okay. So let's do it. We got 10. 2.3 is my standard deviation. Now, I want it between 8 and 11. Okay. So let's run through this again. I know I hit menu. Oh, looks like that purple showing up. Let me try that again. There we go. Let's try this one more time. Menu. There we go. So I know it was statistics, distributions, normal CDF. Okay. Now we want it between what? 8 and 11. So this time we have a lower and an upper. So I'm going to go ahead and say 8, 11. Okay. Then my mean was it 10? 10, and I believe the standard deviation was 2.3. Okay. There we go. So there's all my information. Okay. So when I push OK, looks like I have a percentage of about 47.6%. If you want to round it to one decimal place, make it 3 sig figs. Okay. About 47.6. Is everybody getting that? About 47.6%. Is there anybody who did not get that? Okay. Well, let's try B. So find the probability that my element is going to be less than or equal to 12. Okay, so again, using those inequality symbols, if I'm less than or equal to 12, 12 represents my what? Upper or lower? 12 is going to be an upper. Okay, so I have the same information. Let me go back over here. It was menu, statistics, distributions, inverse, not yet, normal CDF. Okay, so we want everything less than 12, and it doesn't matter if it said strictly less than 12 or less than or equal to. Equality will not change what we're doing. Okay, so because we only have the upper, I'm going to leave that lower. I'm going to put in the 12. Okay, we had a 10 for the mean, and then a 2.3 for the standard deviation. Okay, so what am I going to get when I push OK? I'm getting about 80.8%. Okay, 80.8%. This is one of the easiest ideas we have in IB. Okay, you're going to want to see these on your paper exam. Okay, 80.8%. Okay. Now, the one thing I'm hoping, and this is just kind of me thinking out loud, this coming summer, they are changing the IB curriculum. You know, in years past, they would have you do this by hand. You remember I told you there were pages of numerical table values, and you would have to find the correct percentage, finding those Z-scores. I'm really kind of hoping that I don't go to the professional development this coming summer and they say they're bringing that back. I just don't think that's going to be useful. I have no idea what changes they're making. But it doesn't matter to you guys because now we're good, right? Okay. Okay, like I said, I'm just thinking out loud. All right. The probability of X being greater than 9. Again, doesn't matter greater than or equal to. 9 would represent my what? That would be my lower boundary. Okay. All right, so I'm going to come on over here. Let me go ahead and document B out of this. Give myself a little more room. So menu, statistics, distributions, normal CDF. Okay, we want everything, what was it? Greater than 9. Okay, so 9 is my lower. Okay, what do I do for the upper? 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Okay, then we have 10. Now I just want to do that the whole time. 9999999. Okay. So what should I get when I push enter here? Okay. I'm getting about 66.8%. That's exactly right. That's it. Okay. 66.8%. Now, it's really easy to find these values. Okay, it's not very challenging, but is everybody making the connection? Is everybody understanding what this actually means? Everybody's okay. Okay. Now, this next one, the very first year I taught this, I went ahead and worked that problem, but you're not going to be asked to do anything like that. That's why I've already got it marked out, so not going to worry about this. Now let's talk about what if we need to reverse the process. What we're trying to do is find a particular element or elements that represents a certain percentage of your data, right? All the answers we've been getting up to this point are percentages, okay? Well, what this is saying is, what if we reverse the process? What if you're given the percentage, but you want to work backwards and find the element in the data that would represent the starting point for that? Okay. Now, this means it's still the same thing. So X is normally distributed with a mean of what? So the mean is 12.4. Okay. There we go. The 1.3 squared, now with the square, remember that's the variance. So what's my standard deviation? It's just the 1.3. Okay, so there's my sigma x. Okay, so here's what you're going to want to do. Let me go ahead and kind of show you this graphically. Again, if I were to go ahead with this guy right here, we know that the mean is 12.4. So beneath this curve, it represents how much of the data? What was that highest percentage we were looking for? 99.7. It's the only decimal percentage you actually have to remember. If you remember 68, 95, 99.7, perfect, good to go. Unfortunately, that will not be in the formula book. That is something that you're going to have to remember. What we're looking for here is the element, let's say K right here, where all of the elements below it make up 75% of the data. Okay, that's what we're looking for. If I put all the data elements from smallest to largest, find that one element where from him below is 75% or 3/4 of the data. So is everybody okay with what we're doing? Okay. Well, here's what you're going to go ahead and do. You already have everything you need. The keystrokes are virtually identical, but you're going to choose one different option at one point. Okay, so let's remember these numbers, 12.4, 1.3, and we have 0.75. Okay, so I'm going to come on over here. I'm going to say menu. I'm still going to go to statistics, distributions, but now I'm not trying to find the percentage. I'm using the percentage. So what do you think I'm going to choose here? The inverse normal. Okay, the inverse normal. When I choose that, you'll notice it has only 3 tabs to fill in, and we have all that information. Okay, the area, well, that's my percent. We know it's 75%, so I'm going to go ahead and plug 0.75. The mean, well, what was it, 12.4? Okay, and then the standard deviation, I want to say 1.3. Is that right? Okay, 1.3. There we go. All right, so there we go. I click OK. The element I'm looking for is actually 13.3. Okay. Now we have no idea what the data elements look like, but I know that this element here, all the numbers that come before it should represent 3/4 of the data. 13.3. And that's all there is to it. Okay. 13.3. Okay. How's everybody doing? Now, I'm already looking around and I see people moving on to the next one, but there's one thing, and this is crucial. They love to put these problems on the paper exams, and the problem is we're still at the very beginning of the school year, and it's very, very easy to forget this. Now, we can only find these kind of problems, the solutions, on the calculator, right? Okay. The calculator can only handle less than. Do you notice anything about B? It's greater than. Okay. So if you're given the percentage and you're trying to work backwards to find an element from the data set, you have to do a couple of things. Because it says X is greater than K, I'm going to rewrite this, the probability of X less than K. Okay, you can only look less than, but you have to take 1 and subtract the percentage you have. Okay, that's the rule. Your calculator can only handle less than percentages. Okay, so if it's greater than, you simply switch the symbol, but you have to remember to subtract it from 1. So why do you think we're subtracting it from 1? What would 1 represent? 100%, right? All the data. So what I'm actually looking at here, the probability of X less than K is equal to, what would that be? 0.08. Okay, now you have the correct information that we can put in the calculator. Okay, so let's see what we got here. Okay, so I'm going to go to menu, statistics, distributions. What do I choose? Inverse normal. Okay, so because it was greater than, I'm not putting in 0.92, I'm going to put in 0.08. Then we had a, what was it, 12.4? And a 1.3. Okay. All right, would everybody agree? What do I get when I push OK? I'm getting like 10.6. Is that what you guys are getting? You got something different, man?
Oh, I forgot the 0.4.
Oh, there you go. Yeah, you put in 12. Okay. So 10.6. And there we go. Anybody having a hard time? Anybody confused? Okay. Well, I think there's one problem left. Okay, a university professor determines that 80% of this year's history candidates should pass the final examination. The examination results were approximately normally distributed with a mean of 62 and a standard deviation of 12. Find the lowest score necessary to pass the exam. Okay. All right, so try this one on your own. Okay. Try this one on your own. So you have to ask yourself, is it going to be more like A or B that we just did? Okay, now while you guys are doing that, if you do happen to finish, I would encourage you to go ahead and start looking at the homework because you'll definitely need a calculator, to help you out with that. And I'm going to pass back some papers. Oh, and somebody did turn in the cumulative frequency homework, but they didn't put their name on it. So if you happen to notice in front line that it's got a 0 or an M in there and you turned it in, come on in and let's take a look at it. All right, so Elizabeth. Okay. John. And now I'm about to pass out the internal assessment topics. I read through those during my 7th period PLC, and I also took some time after school to go ahead and finish those up. A lot of really good topics. I wrote some feedback on these. So if you have any questions about that, or you need a little more guidance, just come on in to see me, or if you just have a question in general about why I wrote what I wrote. A lot of people have really good topics. Some of them are pretty ambitious. Some folks, I think you may want to tweak your topic a little bit, and I probably said something to that effect, because the biggest problem I'm seeing in any that there were a problem, basically it's getting the data. The whole point of the IA is to be able to collect data on something that you can analyze and interpret. You can come up with your own conclusions. Okay. Now we definitely need to be thinking about data, because when is your outline due? On the 30th, at the end of this month. Okay, so this one, just by turning one in, everybody got a 100. I'm just providing you feedback on this. For that outline, the only way to get the maximum credit 100 is if I see data. Now, you don't have to be doing anything with it yet, but I would like to see, are you collecting data on your own? Did you use an internet source? Whatever the case is. Okay? Because the more I see, the more I'm going to be able to help you. Ella. You.
I think.
You think it might be yours? Okay. So I'll grab that in just a second. Okay. Let's see. Emma. Okay. Gabriella. Amy, Matthew, Madeline, Lizzie, Courtney, Katie, Stephanie, Joe, Ethan, Naya, Emmy, Joey. Okay. Sir Beth, would you pass that to Laura, please? There's Sir Beth. Then I got Ethan W. There you go. Then Elizabeth. Jenny Lee. Nolan. There you go. Jan. Reese. There we go. Lucas. There we go. Okay, John Henry. I didn't write anything on yours because you came in this morning and we talked about it, so I figured that would just be kind of redundant. Courtney. Lizzie. Reese, would you pass this to Laura, please? Thank you. Okay. Then we got Reese. There you go, ma'am. Then we have Bradley. Lucas. Uh-huh. Madeline. Joey. Nolan. Jacob. Jane. Joey. JD. John Henry. And Elizabeth. Okay. Let me see. Jacob, is that yours? Okay. Thank you. Okay. All right. Anybody think they got the answer? Okay. Joey, what'd you get? 51.9 is exactly right. Okay. So he determines that 80% of this year's history candidates should pass the final examination. Okay. The examination results were approximately normally distributed with mean 62 and a standard deviation 12. So if I were to write it out, X is normally distributed, okay, with a mean of 62 and then a standard deviation of 12, and then they always square it, okay, to go ahead and form the connection with the variance. Okay, find the lowest score necessary to pass the exam. So what we're looking at here is the probability of X being greater than 80%. Oh, sorry. Being greater than K is equal to 0.8. Okay. Because 80% of them are going to pass, so this should end up being a greater than. Okay. So greater than what value represents 80% of the data? Is everybody okay with that? Okay. But which one is this going to be like? Is it part A or part B that we just did? Part B, we don't want to forget. If you're greater than the element you're looking for, you need to rewrite it. X less than K, which is equal to 0.2. Where'd you get that 0.2? There you go. You always take one, the 100%, and you subtract the percentage that you're given. Okay. So basically, what I'm looking for here, if I've got all these scores, okay, I'm looking for a particular score, like this guy right here. Now, why do you think I put that score right there? Why do you think I put it in that location on the normal distribution curve? Because this represents what? The lowest score necessary to pass, right? And remember how many people passed it. So that's why the 80% would have to be above that. This is the minimum. So anybody below that value, they unfortunately didn't pass. Okay, so if I come on over here, let me document B out of this. Let's see here. It was menu, statistics, distributions, inverse normal. The area is now 0.2. Okay, because remember the calculator can only handle less than when you're looking for that term. And what was my mean? 62. Okay, and the standard deviation was 12. Okay, there we go. Joey is absolutely correct. I got 51.9. Remember, now this is not a percent. This is an element in your set of data. We use the percent to go backwards. Okay. Good. Any questions? Anybody having a hard time? Okay. Well, here is the homework. So you'll notice, you see exactly why you're going to need a calculator. Okay. It looks like a lot, but once you really just start typing these in, it goes a lot faster than you think. Okay. I would encourage you to definitely go ahead and practice, get that turned in by Friday. There is one, I would say probably the most challenging problem on the entire assignment is going to be number 10C. Okay. I'm going to be curious to see who can find that value of A for me. Okay. So if you're looking for a little bit of a challenge, there you go. But we can definitely talk about that on Friday or any of these others that you want to. Okay, so we still have like a good 7 or 8 minutes. I would probably encourage you, at least for the next 5, go ahead and hang on to that calculator, try to get as many of those problems done as you can, and then we'll go ahead and put them up and we'll get out of here. All right, how we doing? Jacob's all right? Okay. What about everybody else? Cool. All right.